Okay guys, so I'm back. As you can, if you have watched my past video, I've done 12 problems of the CP31 sheet by Priyansh Agarwal of 800 level. I think today I'll be able to complete till 31, and then I'll start with 900 in the next video. And I think within 4 to 5 videos, I will be able to complete till 1200. And this is just me showing how I think, approach problems, and what do I do when I get stuck somewhere. So yeah, let's start. Okay, let me put up the timer as well. Uh, oh God. Mm, okay. Time not stopwatch. So yeah. Um. Let's start doing problems. Okay. So I'm given an array of length n containing integers and two arrays empty initially b and c. You need to add each element of a to exactly one of the b or c in order to justify the following conditions. Both arrays b and c are not empty. More formally, length of b and length of c is greater than or equals to 1. And for any two indices, okay, I think last time I was able to solve this problem, but I did not submit this. I was missing some test cases, I think. Um, yeah, I have to print here -1, and okay, so I'm given 5, and okay, shit, this is not the problem. This is some, okay, so I'm given 6 by this, it should be, okay, let me copy the test cases, and let's see. So first is -1, then we have 4 and 1, then we have 2, 3, 4. Okay, why do I have 2, 3, 4? Okay, this in this test case, so yeah, 1 and then 2, 3, 4. So the question stated that, again, I don't have 5 here. I should have 5 as well. Yeah. Hmm, maybe I should go till equals to. So yeah, I was missing one of the points, and now let's see. So okay, this 8 should come here. Okay, so I subtract 1 and then. Oh God, got the point. Okay, this is useless for some reason. Okay. Uh, what is this that I'm printing? Yeah, and hence equals to x, and I think I need to store this value. Int x equals to mp of air of n minus 1. That means the count of air of n minus 1. Let's also have like int y, which will store the value of n minus 1, because I have to print that value now. So I can just print here y. Okay, and mm, okay, okay. Let's see. So the I also print the sizes as well. Cout n and cout. So yeah, for any, the question is that for any value of like I'm given an array B and an array C, and the length should be greater than or equals to 1, and then for any two indices Cj is not a divisor of Bi. That means what this means is for any Cj, Bi mod Cj must not be equals to 0. So what I have done is like I have searched for the maximum element and I have put it in one place, and all the other elements will be in that place. And since there is no 0, so anyway I can do this, and the answer should be right. You can see here. Okay. Mm-hmm. This is problematic. So 6 and 1, yeah, right. This is 9, and then 3 and 2, and then 2 and 1, and then 1, 3, and 5, and then 1, 2. So I think this should work. And let's submit this. Yeah. Okay, so we're done with problem number 13. So Anna and Katie ended up in a secret laboratory, and there are A plus B plus C buttons in laboratory. Not A buttons can only be pressed by Anna, B can only be pressed by Katie, and C can only be pressed by either of them. Anna and Katie decided to play a game while um, taking turns pressing these buttons. Anna makes the first turn. Each button can be pressed at most once. So at some point, one of the girls will not be able to make the third turn. The girl who cannot press a button loses. Determine who will win if both girls play optimally. Okay, so there are like what this question says is that some A buttons and then B buttons and C buttons. If like what I feel is, let's say Anna presses her first button, and then Katie will try to. I think both of them will try to press this button first and get rid of this, so that after one has gotten rid of these buttons, then the only thing left is who has more number of buttons. Uh, yeah. So if let's look at test cases. If I have 1, 2, and 3, so I will press this button first. Now you have 1, 2, 2. Kate will press this button first. Now she has 1, 2, 1. I will press this button. Now it is 1, 2, 0. Kate will press her button. Now it is 1, 1, 0. Now Anna will have to press her button, so it is 1, 1 0, 1. Now Kate will press her button, so it is 0, 0, 0. And now Annie cannot press this button or this button, so she will lose. Okay, another test case. 6, 6 and 9. So let's say all of them press these buttons, and now there are odd number of buttons. So who will get the chance if there are odd number of buttons? If there are odd number of buttons here, uh, if it is an even number, so Anna, Katie, Anna, Katie, Anna, Katie, Anna, Katie, right? And now it's turn for Anna to press a button. Otherwise, if it's an odd number, then Anna has already pressed, and now Katie has to press. So that means one extra button goes to Anna. Okay, and now she'll press her button. So it is like 7 and 6, and the turn is also of Katie. So 7 and 5. Yeah, and I think otherwise if it's even, if it's even, if it's like 8, so Anna, Katie, Anna, Katie, Anna, Katie, Anna, Katie, and so on. So now it's to press, Anna has to, like 8 is there, so now Anna has to press a button, so it will be 1 and 2, then again she will has to press one button, so it is 1 and 1, and then it's 0 and 1, then it's 0. So if it's 2, 3, or if it's 2, 1, then Anna wins. If it's 2, 2, then Katie wins. So the number of buttons Katie, okay, I think I got the problem. It's basically saying that you just take uh, the values as input, int a, b, c, c and a, b, c. All of the a, b, c are at least 1. So what I'm doing is, if c mod 2, then as you saw that Anna gets one more chance, and Katie decreases the chance by one. In that case, now I'll see if yeah. So now I'll see like if it was 8 and she has 5, so now it becomes 6. This becomes 7. Even in this case, Anna will win. If it's 7-7, even in that case, Katie will win. Katie will win. So the number of buttons Katie has must be less than or equals to um, if B is uh, less than A, C out first, else C out. And yeah, let's see. Okay, first, and then here it should be second. Why second? So she has odd number of buttons. Okay, 1, 2, and 3. So now it's Katie's turn, no? So Anna's already pressed this button, so now it's Katie's turn. So it would just get decreased by 1. Yeah, this won't happen. Okay, I think this is correct. Let me think of another test case. Uh, like if it was 1, 2, 2. So Anna presses button, Katie presses button. Now it's again Anna's turn. So uh, now the question is totally dependent on. Okay, I think this works. Mm, mm, mm. Okay, you're given an array consisting of n integers. It asks you to determine whether it is possible to color all its elements in two colors in such a way that the sum of the elements of both colors have the same parity, and each color has at least one element colored. Okay, it asks you to determine in such a way that the sum of the elements of both colors have the same parity. Mm, what does this mean? Like all its element, I have to color in two colors in such a way that the sum of the elements with the sum of the blue elements is 6 and the sum of the red elements is 18 have the same parity. Okay, okay, okay. Got it, got it. So mm, basically, what this means is that let's say I've colored blue elements, then that should be odd. If it's even, then okay, okay. Mm, mm. So in what case can we do this? So let's. So this just boils down to I have to count the number of odd and even elements. Let me show you what I'm thinking. So what I'm basically thinking is like mm, let's say I have 5 odd elements and 6 even elements. In that case, it won't. In that case, it is possible because I can split this here. In that case, it won't be possible because if I segregate out one odd element, then it becomes 4. So basically, I have to count the number of odd elements, right? And yeah, guys, my typing speed is not so slow. It's just that it's too cold and I'm not used to this cold weather. My hands are getting a bit numb. So I can count odd is equals to 0 and then comma count odd plus is equals to it and it uh, mod 2, right? So now I have gotten the count of odd elements. If count odd mod 2 is equals to 0, then it is possible. It is always possible if the count of odd elements is even. Let me show you a case. Let's say we have 6 odd elements and 0 even elements. I can just split in 3 and 3. Both of them have the same parity. If it is 7, uh, then it is not possible. If it is like 4, I can split on 2 and 2, and then both of these are even. Okay. Okay, sometimes people do get confused by the seeing like n is so small and ai is also so small, so they start thinking in terms of whether we have to apply some recursive solution, have to generate all possible answers. But by practicing I came to know that it is simply because we cannot test it in less than like n k power 6 or some fashion. Yeah, it's not because they want to you to specify the Current array sorted if a1 less than equals to a2 is less than equals to an, and Radaris is an array a choose an index. You can perform these. He's allowed to perform one type of operation, right? Zero number of times. Choose an index i's and add one to a1 to ai and subtract one from a1 ai plus 1 till an. The values of a can be negative after an operation. Determine the minimum operations needed to make a not sorted. Okay, it is sorted. I want to make it not sorted. Okay, so yeah, again, what this means is like I have an array A, which is let's say 1, 8, 10, and 13, and now I want to make it not sorted. So answer is like from here I'm okay. Does it include I? Yeah. So from here I'm decreasing, and from here I'm increasing. So this becomes 11. For okay, I'm adding here. So this becomes 1. This becomes 2, 9. This becomes 9 and 12. And again I have to subtract 1. So this becomes 3 and 10. And this becomes 10 and uh, sorry 8 and yeah. So basically for any one element do this thing, and now then it would be not sorted. For example, here I can just keep one index here and make it like not sorted. So basically 1 and 9. So how many, what is the difference? The difference is 8 and the difference is 5. So obviously the answer is minimum difference uh, plus 1 by 2 plus 1. Minimum difference by 2 plus 1. Answer is that. Yeah. Already taken the input. Let's just do one thing. Int diff is equals to int max for int I is equals to 1, I is n I plus plus, and diff is equals to min of diff comma error of I minus error of I minus 1, and answer is so why is the answer diff by 2 plus 1? Because the difference here becomes 2, but as you can see if I apply two operations then this becomes 11 and this becomes 12. So after I apply one more operation this becomes 12, this becomes 11. Even if it was equal, like if it was 8 and 14, so this becomes 6. So after applying three operations this becomes 6 and this becomes 11, and I need to apply one more operation that this actively becomes increasing, otherwise it is not sorted. And yeah, let me copy the test cases. Oh god. Okay. Array, again, if the difference is ever negative, answer is Mm, yeah, this should work now. Mm, hmm. uh, Buttons, array coloring, desorting. Done with this. Let's go to this. So you're given an integer n for which you want to obtain. Which you want to obtain. You have an unlimited supply of every integer from 1 to p except integer x. There are no integer x at all. You have to take an arbitrary amount of each of these integers. Can you make the sum of the integers equals to n? If there are multiple answers, then print any of them. Okay, this is again. I don't even think I need to read like the test cases. This is int n is given and what else? K is given, x is given, k and then x, right? So if x is not equals to 1, answer is yes, because I can take an arbitrary amount of any ones and then mm, otherwise else that means x is not 1, then answer is yes. Otherwise if the answer is 1, then I will try to make it by using 2's and 3's, right? So let's see the numbers we can make it 2's and 3's. So by 2, 3, 4, 5, 6. Can I make 7? Yes. Can I make 8? Yes. Can I make 9? Yes. Can I make 10? So let's take two of these and this two of these, so this becomes 10. Can I make 11? Yeah. Okay, I have to print that also, no? So while n minus minus, just print 1. And I think I have to print the number of operations as well. So yeah, this becomes that. Otherwise, let's see. So t is always greater than equals to 1. No. Okay. Okay, I did not consider this case. Like k has to be greater than 1. If k is equals to 1, then answer is no, because there are no integers now. Again, I think I can make any integer using 2's and 3's. Is this true? Uh, any integer is the sum of this 2x plus 3y equals to n. Is it true? Mm, I think this is true because ax plus by is equals to n, and then a and b are co-prime. Hmm. There are twin primes. Okay, so we have 5, 2, and 1. Else, like if k is less than 3 and if n mod 2, uh, then answer is no. I only have 2, I cannot make an odd element out of it. Else, I think we can make, let's see if we can make 13 using 2 and 3. So 2, so 3 plus 3, 9, plus 4. Yeah, right. We can make it, let's see if we can make 17. So that is, yeah, we can do this. Else, answer is, else the answer is yes. Okay, how do I get this? So int x, let's call y is equals to n by 2, and while y minus minus 2 and then okay, oh sorry, not and then it should be space, and also over here it should be space. Okay, so after printing yes, I print the null operation, then I have to print this. Okay, now I have to print. I can make it using twos and threes, so it is always possible. All I need to do is like keep. I will keep on taking two, and then instead of taking one, I'm taking three. So I'll subtract one, two. So let's do n minus three, and then I'll print n. But if it's n is even, then let's subtract two threes. If n mod 3 is equals to 0. Okay, in that case I don't need we need a 3, right? So I will just do while n int y is equals to n by 2, while y minus minus c out 2, c out y, and c out and then okay. Else the thing is that I can subtract 1 2, so n minus is equals to 3 int y is equals to n by 2, and answer is y plus 1, and again the same thing. The only difference is I will at the last unit 3. Okay. Yes, 10. This sums up to 10. Then we have no. Okay. Where am I not printing handle? Okay, over here. First yes, and then okay. Yeah. Also print y. So this sums up to 4. Then we have this sums up to 7. This sums up to 6. Okay. Again, the thing is that I did not consider is okay. Wait. Okay, we have to return them. If x is not equals to 1, uh, else if x, okay, here also need to consider that if k is equals to 1. Let's see, if x is not equals to 1, then answer is always yes. Apart from when k is 1, then we have no element. Okay, now we move on. If k is equals to 2 and x is not 1, then we can make it. Now we move on. Now if x is not 1, then k can obviously not be 1. So x is less than equals to k only, no? So why are we even entering this case? Yeah, x is equals to 1. Okay, yeah, I was. This is not needed. If x is not 1, uh, then anyway k must be greater than 1 only. No? So here I have to consider if k is less than 3. If k, what if k is equals to 2? Yeah, in that case, this is so this remains only is k is equals to 2, and yeah. Mm, hmm. Uh, yeah. Mm. You're given two integers x and k. Grasshopper stands on a point 0 and OX axis in one move. He can jump some distance that is not divisible by k. To the left or to the right. What is the smallest number of moves it takes the grasshopper to reach point x? It can jump some integer distance that is not divisible by k to the left or the right. So for the minimum number of moves, what he will do is mm, again k is greater than or equals to 2. That is a big hint. So answer is always k. He will jump to a distance k minus 1 for the minimum number of moves. For example, if it is 10 and 2, then he'll need to jump. Okay, no, 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 no. Okay, got it. So what I was thinking that he can jump only till k, but he can jump any distance, which is like not. So the answer is simple. It's either one or two. So if like I'm given n and k, no? So like if n mod k is equals to 0, then he would need two jumps. Uh, Otherwise, he would need just one jump. Why am I so sure? Like if it's n mod k is not equal to 0, then he can jump till that position, no? So if n mod k is not equals to 0, C out 1 enter and C out n enter. Otherwise, answer is 2, and he will jump like to n minus 1, and he will jump 1. Okay, yeah, I'm sure. 291, 110, and 13. Okay, makes sense. Like 7 and 3 and 9 and 1 is the same thing. Um, okay. You're given an array A of length n, which elements are equals to minus 1 only. Let's call the array equal if the following conditions hold true. So the count of okay. The number of ones must be greater than number of minus ones, and the product must be 1. That means, did you get this? So this is like so what he's saying is I need to make count 1, which is a number of counts of ones, and then count of minus 1. 1 1 is equals to count of that. Minus 1. So if error of I is equals to 1, I will do count 1 plus plus, else count 1 1 plus plus. So okay, oh sorry. Now I need to find the minimum number of versions to make the array A good. So if it is okay, I have done this problem before, but doesn't matter. I don't remember the solution. Anyway, I have to come up with solution. So answer is, if I only have count of minus ones, I have count of minus ones. Let's say x and then count of 1. So the thing is, if y is greater than x, it is true, and x mod 2 is equals to 0, right? So if count of 1 is greater than count of 1 1, and if count 1 1 mod 2 is equals to 0, answer is 0 operations needed, because everything that mentioned is already true. Like if I have 5 and 4, so the count overall, the count of array is 1. So if it is greater than equals to even 4 and 4, that sums up to 0, and it is otherwise. Otherwise, what happens is, like, this means that the count of array elements is odd. Okay, if the count of array elements is odd, yeah, if the count of array elements is odd, like let's say 5 and there I have 3. So if I sum up them, the first condition is true, but if I product them, then the answer is -1. So I'll just need to subtract 1. Answer is 1. Okay, and now comes the second condition. If count of 1 is less than count of, so now let's look at the conditions here. Like if I have 2 and here I have 3. So if I convert 1, then the answer becomes 3 and the answer becomes 2. Let's say I have 2 and 4, then the answer becomes 3 and the answer becomes 3. Okay, so let's say I have 3 and 5. So I subtract 1 and answer becomes 4 and the answer becomes 4. So now what I think is answer is minimum of, answer is the difference between them. Like if I have 5 and let's say I have 8, so the answer is difference by 2. If the difference is odd, so this becomes 6, and the count of -1 should become decrease by 1, so this becomes 7, and then I have to do it one more time. So this becomes 7. Okay, I think let's find the difference is equals to count of 1 1 minus count of 1. If difference is positive, then what has to be done is, so like let's look at the one of the test cases. So in the test case, like 0 and 3, so 3 minus is 3, and here I need 2 uh, steps, right? Actually let's have a count variable, which is the number of steps that I need, and instead of printing this, let's print count plus count plus, right? So from count of 1 1, I'll be subtracting diff by 2, and from count of 1, I'll be adding by 2. Okay. Now the count of 1 will always become greater than count of, like, negative ones, and the count plus will be equals to difference. Why? What's the problem? Like if it was 3, then the answer. Oh god. Okay, again I need to consider difference. So let's do one thing. Diff plus 1 by 2, diff plus 1 by 2, diff plus 1 by 2. This is a trick that I learned, so that okay, 1 1 0 3 0 1 2. Yeah. So basically, there are conditions like when the difference is 3, the answer is 2 instead of, like, what is 3 by 2, that is 1. So in that case, all you need to do is 3 plus 1 by 2. And when it is even, so answer is 1 only. In that case, all you need to do is diff plus 1 by 2, and you will get the right answer. I think, mm, please don't give me wrong on test case 2. Yeah, accepted. Mm-hmm. There's still a lot of problems to go. It's been 40 minutes. So you're given permutation of length n. You have find any permutation of length n such that a1 plus a2 is a1 plus b1 is less than equals to b a2 plus b2 is less than equals to a3 plus b3 is less than equals to an plus bn. It can prove that a permutation b satisfies the permutation always exists. The permutation of length n is considered okay. Is permutation be made of a? I think it has to contain the same elements as A. Okay, again permutation is of A. Hmm. Hmm. Yeah, make all elements equal. Okay. Hmm. Hmm. Make all elements equal. All elements will be equals to what? They'll be equals to the clear trick is that it is a permutation of length n, and it always consists of distinct integers from 1 to n. So we have 1, 2, 3, 4, 5, let's say. Then the answer can be 5, 4, 3, 2, and 1. So this becomes equals to 6, and yeah, answer is n plus 1 minus error of I. Keep printing. N plus 1 minus error of I. Okay, answer is this. Okay, so this is intuitive. Let me prove to you that the answer will be this always. So he's saying that I need to make all these elements equal. All these elements less than or equals to. So I can make all of these elements equal to some value. Why? Because uh, if you see, these are all like mod 6. Just some elements that are coming, and you can consider them to be mod 6. So if I subtract 6 minus this, I will get some element which is less than 6, and it will always be unique since the input elements are unique, if that makes sense. Full competition is done, blank space. uh, okay, this is simple. We given a binary array consists of zeros and ones. Blank space consider elements consisting only zeros. It has to find the length of the longest blank space. Okay. Mm. So in here I'll take a vector, and I'll consider that the numbers are starting from 1. So I can push back n, and then I'll like for in I is equals to 1, I is less than equals to n, I plus plus. If let's take in x, in x, if error of I, if x is equals to 1, that is yeah, that is the consecutive difference between any two ones. Then I'll push back uh, I, and in the last I'll push back n plus 1. Okay, and now the answer is simple. It's just the maximum difference between any two ones. Why I'm taking L dot size here? Because otherwise I have to do like n and n plus 1 and all sorts of things. Right, so answer is max of diff comma error of I minus error of I minus 1 and okay. Hmm. Yeah, that should be the answer. Either this or it's like 3 2. Yeah, yeah, got it. It should be minus 1. Why minus 1? I have to do oh, like here over is 1. Yeah, I is 1 and then 1, 2, 3, 4, 5. But in between 1 and 1, 2, 3, 4, 5. 5, but in between 1 and 5 there are only 3 zeros. So yeah, minus 1 has to be done. Let's do it here instead of here. Yeah. Mm, mm, mm. We have two denominations of coins, 2 and k bullies. To ask you remind whether it's possible to represent n bullies in coins, whether there exists the non-negative integers x and y such that 2x plus ky is equals to n. Okay. Again, I think this is some property like of mathematics that I can express n as a number sum of ax plus by provided a and b are co-primes. Let's say a is 2 and it is 7, then it is always possible. So if n is even, answer is always true because x is not y are non-negative, so x can be completely 0. And n, if it is 1, then it is never possible. If n is 1, then it is never possible. Okay, provided k is not 1. So if k is 1, answer is always true. Otherwise, they must be twin co-primes for that to happen. In x and in k. Now, if n mod 2 is equals to 0, answer is always yes. Or k is equals to 1. Answer is always true. Otherwise, if n is equals to 1 and k is, now that means k is not 1, then answer is always no, because it is minimum. So k will always be less than or equals to n. Okay, let's say k is 9 and it is 7. If it is 11 and it is 13. So if the GCD, if n is odd, or if n mod 2 is equals to 1 and k mod 2 is equals to 0, then it is always no. Otherwise, let's say, so the difference between 2 and k must, otherwise answer is always yes. Yes, yes, no, yes. So the thing is, if n is even, answer is always yes. So that removes one case. Or if k is 1, answer is always yes because I can make y by k equals to n. Otherwise, if n is 1, if n is 1, answer is always no. Because if n is 1 uh, and I have k and k is not equals to 1, it is given. So again, this is not needed because k is always less than equals to n. If n is 1, then k is also 1. So n mod 2 is equals to 1 and k mod 2 is equals to 0. That means it is a k is a multiple of 2. Then you can never make since n is odd and k is not odd. So you're adding even and even can never add up to like odd. Okay, and now yeah, that should be the answer. Hmm. Yunkin is standing in an infinite plane Cartesian coordinate system, and in one which you can move diagonally to the adjacent point on the top right or the adjacent point on the left. She can move to point x plus 1, y plus 1 or point x minus 1, y. If it is impossible, so okay, he needs to move to a comma from. It's said that she's currently at a comma b and she needs to move to c comma d. So in one move she can be like a plus 1 comma b plus 1, or she can be like a minus 1 comma a minus 1 comma y. So the thing is, this means that if d is smaller than b, answer is minus 1. Otherwise, it's always possible to move from a to this point. A comma b comma c comma d. If d is less than b, answer is minus 1. Otherwise, yeah, return. Otherwise, let's see how many the difference between y. It would be equals to d minus b. Okay, so that is the number of diagonal steps that she must take. And let's see the difference in x. So now this difference must be subtracted, must be added to a. Yeah, so a plus is equals to diff of y because she has moved there that by that much. Now we'll see the difference in x. So that would be equals to c minus a absolute of this value, and answer would be, so here's the answer is 4. Why? So difference is 2. That means minus 1 0, minus 1 and 2. Initially she moved y. See out difference of x plus difference of y and then, and yeah, it should be the answer because anyway I will have to move towards y. So 4 6 uh, y. So I can move 2, no? Here it's saying that the answer is minus 1. Let's see why. So minus 2 minus 1 1 and 1 So I can move from x to x plus 1 comma y plus 1. Okay, from a comma b, right? So she moves to minus 1 comma 0, and then she moves to 1 comma 1 comma 1 comma 1. This is possible. mm, a b c d, right? Why this is not possible? Okay, let me see again. Minus 2 minus 1 1 and 1. So she'll go to point minus 1 comma 0, then she'll move to point, what is it? Oh god. Okay, after this, x and after this they're at the same position. mm, Minus 2 minus 1 1 and 1, so she moves 0, this becomes 1, then she moves 2. Okay, no. So this becomes like 0. Okay, now, okay, she can move to x minus 1 now. If difference of x is negative, return, and it should be a minus c. Yeah, maybe I'm not explaining too much or not speaking aloud my ideas, but whatever is coming to my mind, I'm trying to say. Okay, we just need 8 more problems and then we'll be done. Mm, let's. I'll be quicker now. It's an area of non-negative images B. You need to choose B I is equals to A I or X for all where B. It is possible to choose some X such that the value of the operation is equals to 0. It can be shown that the number always exists. Then there are also this X such that, okay. So for each bi, I have to choose an x such that bi is equals to ai's or x, and x is and this separation evaluates to 0. So answer is XOR of x is done n times, and ai, yeah. So mathematical expression is this, like ai XOR x. So let's say I have 5. So b1 XOR b2, or just b, yeah, b2 XOR b5. So this becomes a1 XOR a2 XOR a5 XOR x XOR x is x only. 1 XOR 1 is 0. Okay. Anyways, the answer I think should be this XOR x. That would evaluate to 0. Again, I'm not so sure, but I think like 1 XOR 2 XOR 5. So 1 0 1 and 1 1 0. So this becomes 1 1, and then 1, and then XOR 1. So this becomes, I have to prove if it is not possible. Okay, this case where it does not exist. It does not exist when the length of the array is even, and it does not evaluate to 0. So when will there be case when x does not exist? So if n is even, all of these x's will get cancelled out. Like if I have zeros or ones or zeros or ones or twos or three, this 1, and then ones or 1 is 1, and this is 3. So again, if I have 1 2 2 3, so 1 or 1 becomes 3, 3 or 3 becomes 0, and then 0 or becomes 2. So if, yeah, so in that case, I'm thinking of making like templates for inputs, like for and such things. Mhm, mhm. If n is odd, the answer is always yes. if n not 2, answer is x handle. Otherwise, if XORs, no, wait, so zeros or ones or twos or three. So I'm XORing four times. Four times can be anything. Four times XOR of x XORs. Uh, Otherwise, XORs is not equals to zero. Answer is else. Answer is zero. Uh, mhm. Mm, usually this usually this means that I'm doing some. Oh God. Mm. Please don't tell me code forces is down now. थोड़ा सा शर्माए, थोड़ा सा घबराए, झिड़के यहाँ से वहाँ, खोले आँखों में सब कह दिया, बोले, जिया बोले, okay, yeah, done. I'm done with we need the zero as well, and append and append. So Timur initially had a binary string S. He performed the following operations several times. Add 0 to one of the string and add 1 to the other. For example, okay, you can obtain either. You could have started with what is the shortest possible string you could have started with. So he's either appending 0 or either appending 1. So anyway, if I find mm, mm, so um, okay, add 1 to the end of string. Add okay. Got it. Hmm. Mhm, 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 mhm. हाँ, सो बेसिकली कह रहा है कि लेट्स से मेरे पास एक एम्प्टी स्ट्रिंग है तो मैं पहले वन ऐड करूँगा इधर, जीरो ऐड करूँगा फिर जीरो ऐड करूँगा इधर, वन ऐड करूँगा इधर। तो अब मेरे को तुम बताओ कि जैसे वन वन है तो ये कभी मैं कर ही नहीं सकता हूँ, एक साथ दो वन ऐड नहीं कर सकता। जीरो वन कर सकता हूँ या वन जीरो। तो बेसिकली काम काफ़ी सिंपल हो जाता है, है ना। एक पॉइंटर रख लूँ और दूसरा पॉइंटर वहाँ पे रख लूँ और दोनों की लेंथ हो जाएगी मिनिमम ऑफ दैट। ओके। while s is great less than n. Anyways, does not make sense to go till equals to because you'll get just one value. So int x equals to str of s minus 0 and int y is equals to str of e minus 0 if x or y is equals to 1, then we'll s plus plus e minus minus else break, and the answer is n minus s plus 1 handle. 1250311024. Okay. So this is a diff for C, as you can see, and yeah, this was pretty easy. Let's look at the number of submissions on this problem. Oh god, this is 22,000. Okay, let me look at the actual submissions on this problem. During contest, how many people were able to do it? During contest, it was done by 10,000. Basically, everyone who took part was able to solve it. 10,000 people who aren't specialists were able to solve this. Mm. Moko likes arrays. Serval gave her an array consisting of positive integers as a gift. Moko thinks that for an array positive integer, it is good if the greatest common divisor of all the elements in A is no more than its length. And for an array of two, at least two positive integers, it is beautiful if all the prefixes whose length is no less than 2 are good. Wait. If the greatest common of all the elements is no more than its length, okay. She wants to know whether array can become beautiful by reordering the elements in A. Hmm. Got it. Here it is no. Here it is yes. 1 3. Yeah. Yes. No. तो basically GCD 1 होना चाहिए, है ना? अगर GCD 1 नहीं है तो दिक्कत आ जाएगी, और इसको समावेश करेंगे. So if GCD is 1, answer is not always 1. Why? तो बेसिकली ऑड और इवन एलिमेंट्स होने चाहिए, वरना नहीं हो पाएगा. या तो सारे कोप्राइम हो एक दूसरे के. हम्म. अगर GCD 1 नहीं है तो आंसर तो हमेशा नहीं है, हो ही नहीं सकता. लेकिन दिस केस मेरे हिसाब से आंसर होना चाहिए कि एक ऑड हो एक इवन हो, एक ऑड हो एक इवन हो. बट अगेन ऐसा जरूरी नहीं है ना. लेट्स से आई हैव 3 7 9 11. In that case 3 and 7, that this is all good. Mm, Basically, if all the elements of the array are prime, then it is true. Otherwise, all the elements must be co-prime to each other. That's it. That's it. एक मिनट हो गया यार. ओके, थोड़ा सोचना पड़ रहा है इसमें. 800 में सोचने किस पड़ रहा है. So you need to make the array beautiful. That means for every two elements, if for any two elements, I can make sure that if all its prefixes whose length is no less than 2 are good. Mm, ओके, प्रीफिक्स प्रीफिक्स ही देखने हैं ना, प्रीफिक्स तो यही होगा ना। समझ गए ना। तो अगर एक भी ऐसा एलिमेंट है जिसमें कि मैं ऐसा कर सकता हूँ कि इन दोनों को पेयर अप, ओके समझ गया। ओके समझ गया। हाँ, प्रीफिक्स वाला पार्ट देख लेना चाहिए था, उसके बाद तो आसान था सब। ओके, इसमें काफ़ी टाइम लग गया। जल्दी से कोड कर देता हूँ। सो बेसिकली कह रहा है कि अगर एक भी ऐसा एलिमेंट हो गया जिसमें कि ना उन दोनों का जीसीडी 1 है, तो मैं पहले उन दोनों को रख दूंगा, तो अब बाद के सारे एलिमेंट्स का जीसीडी ऑटोमेटिकली 1 हो जाएगा। j is less than n j plus plus, let's like gcd is some int max and gcd is equals to underscore underscore gcd error of I comma error of j, right? If gcd is not equals to 1, answer is no, else answer is okay. Yeah, so okay. एक मिनट रुको, इसका आंसर यस कैसे आ रहा है? 3 और 6 का जीसीडी क्या है? अरे यार इनपुट ही नहीं दिया। नहीं नहीं नहीं, अरे यार। हम्म, अरे वाई इट इज नो। 10 और 35 का जीसीडी कितना है? ये 5 है। 14 और 35 का, 35 और 35 का जीसीडी कितना है? इसमें नो, इसमें यस कैसे आ रहा है? ओके ओके, इज लेस ग्रेटर देन 2, इट सीम्स कि लेस देन इक्वल्स टू 2 चलता है। Find out if an integer k exists such that the following conditions are met, कि product of all the elements before k and product of all the elements after k is equal। ठीक है, कोई बात नहीं। हम एक प्रीफिक्स और सफिक्स एरे बना लेते हैं, वरना उसकी भी ज़रूरत नहीं है। सो इन एरर एंड फॉर इन, जो डायरेक्ट बहुत ही डायरेक्ट क्वेश्चन है। दिस इज लाइक 400 रेटिंग, कुछ देखना ही नहीं है। इक्वल्स टू 1 I is less than n I plus plus। बेसिकली एक एलिमेंट तो होगा ही ना, तो n minus 1 and null by for int, let's call this int 2 की पावर 1000 तो जा सकता है, राइट। सो अब मैं क्या करता हूँ, prod 1 is equals to 0 int prod 2 is equals to 0। अगर मैं मल्टीप्लाई करता रहूँगा 2 की पावर 1000 जाएगा, जो कि सही नहीं है। j प्लस प्लस prod 1 plus equals to error of j is equals to 2 for यही काम मैं बाद के लिए करूँगा j is equals to I plus 1 j is less than n j plus plus prod 2 plus equals to error of j is equals to 2 and if prod 1 is equals to prod 2 answer is I plus 1 and then otherwise answer is minus 1 and del and let's return it complete the function over itself and kill it oh god क्या दिक्कत आ रही है ओके और तो 2 क्यों हो रहा है 1 होना चाहिए ना नहीं तो starting from 1 that's why is it अच्छा okay let's maintain a count of int uh, 2's plus equals to error of I is equals to 2 if 0 answer is and then I can return this is div 2a oh god that's our first wrong address 2 स्ट्रीक टूट गई भाई हमारी स्ट्रीक कंप्लीटली टूट गई ओके सो ए 1 से लेकर ए के तक 0 से स्टार्ट कर लेता हूँ क्यों एक टू इधर हो और एक टू इधर हो हाँ यहाँ गलती कर दी 1 से नहीं स्टार्ट करना था अब से आएगी अब से नहीं आया तो पता नहीं क्या करना okay make it beautiful and I'll call it agree if at least one of the elements is equals to the sum of all the elements before it if there is not agree it is beautiful okay you have to reorder the elements in array is called ugly if it contains at least one element which is equal to the sum of all the elements before it आज मैं ऊपर आसमान के आज मैं आगे ज़माना पीछे you is it given that you are allowed to keep the array if it and if it is beautiful there is no element which is equal to sum of four elements before it okay if it is impossible to reorder the elements in such a way that it becomes beautiful? Answer is no. So what my plan is, if I keep the maximum element at the starting point, then there is no way that I can get like. But if the count of maximum element is again more than uh, one, then answer is no. Okay. Must be, it is equal to the sum of all elements before it. Okay. Mhm. So if it is 3, 3, 6, 6, then if I look at 6, if there is at least one element which is equal to sum of all elements before it, over here ऐसा कौन सा element है? Like 6396 is ugly, the element 9 is equals to 6 plus 3. Okay, so I just need to make sure that there is there is no element that is equals to the sum of all elements before it. Okay. हाँ तो सही कर रहा था मैं, सही सोचा था. So if mp dot size is equals to 1, in that case the answer is no. The answer is no here. Otherwise, answer is sort ar comma ar plus n, and then reverse ar comma ar plus n, and then print it backwards. Yeah, and then just print. Okay, also need to print yes. Hmm. Again, okay. Yeah, this is true when mp dot size is 1. If mp of ar of 0 is equals to 1, in that case this is true. Let's say if it's greater than 1, then what I will do is, let's keep the first element intact and just swap ar of 1 and ar of n minus 2. Okay. N minus 1. Right, so basically what could have happened is uh, that let's say I have 5 and 5, then 5 becomes equal to all the elements of before it. And here I have 6, 3, 6, 6, 3, 3. Right, so again 6 becomes, so yeah. Otherwise, it can never happen. Oh god, oh god, yeah. Oh, just 3 more questions to go. An array is good if all the elements of base of all elements are of different parity. You know that an array of size 1 is typically good. Delete them and insert their product in some position. Find the minimum number of operations to form a good array. हाँ हो गया. 1 7 11 2 13. Count. What is the count of odd elements? 4. Count of even elements? 1. So let's say I pick 1 and 7 and I product them. So now count of odd elements becomes 3. Odd is 1, still 1. Can I do like it, so I have got 7 here, 11 and 13. So 3 and 1, not 2. I have to do it again. The absolute difference between count of odd and even elements must be less than or equals to 1. If it is not, then I'll need to decrease the one which is at the gate. Hmm. Okay, so if MP of 0 is equals to 0, or MP of 1 is equals to 1, then I need to decrease them to the 1, make them 1, right? How many operations would that need? Like, let's say I have 1, 3, 5 and 7. I need to, so at any, I'll take 2, and then I'll take these 2 again. 3 operations. What if it's like 1, 3, 5, 7, 9, 11, 13? And this will take 1, 2, 3, like 1, 2, 3, 9, 11, 13. 1, 2, oh God. 1, 3, 5, 7, 9, 11, 13, 15, 17. So this will take 1, 2, 3, 4, 5. And then for 5 it would take, this is some bit manipulation here. छोटा bit manipulation है लेकिन जो भी डिफरेंस है उसको तुम्हें 1 बनाना है ना? ओके. Then answer is 0. If the absolute difference is less than or equal to 1, then the answer is always 0. Otherwise, I just need to make the absolute difference as 1 or absolute difference as 0. So if it is 1, 3, 5, 7, 9, 11, 13, 15, I will take 1, 2, 3, 4, 5, 6, 7. So in total 7 operations are needed, so it boils down to 1. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 8 है तो 7. One one one. अरे यार. Hmm? Isn't am I missing something? Like three and then five. So I have one, two, three, four, and one odd element. Hmm, like what is happening? Ones plus plus. So what is the error? I'm not understanding. It's, what is this error? Let's move on. अच्छा, okay. Hmm, wait, am I doing it right? So 4 1 2 2 and 4 2. So when is 4 1? Okay. Then I need what is the difference? Okay, I need this. And it is 4 odd elements, 2 even elements. Then why do I need 3 operations? Let's check. So 1, are different parity. The same parity, delete them and insert their product in same position. Hmm, why do I need? Okay, so if it is 4 and 2, like 1 1 1 1 and 2 2, so I can make sure 1 2 1 2, then 1 1. This is different, this is different, this is different, this is different, and only this is same. So yeah, Unique is correct by saying it in just one operation. Uh, in which AI and AI plus 1 are of different parity for I, for all I belongs to 1 till n. Okay. Mm, hmm. Over here we have 4 odd elements 1, 1, 1, 1, and 2, 2. Definitely 1 and AI plus 1 is different 1 and AI plus 1 is different 1, and then I just need to delete this and insert this 1, 2, 1, 2, 1. Is this not valid? Why do I need 3 operations? Select the second and why do I need 3 operations? अच्छा, एक minute. Okay, okay, got it. So this, okay, this. Cha, I thought we can reorder the elements. We cannot. Hmm? Hmm, 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 hmm. ऐसे कैसे हो गया 1 2 wait 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 काउंट 0 कैसे आ रहा है 1 आ रहा है अच्छा ओके अभी तो आगे की अरे ली नहीं है ना शिट 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 यार oh god how do I stop this build Hmm, hmm. अरे shit again I'm not doing J++. 304. Okay. Why 304? Hmm. अरे यार, I is equals to G. ये 3 है तो 2 ऑपरेशंस एंड 1 ऑपरेशन. So एक मिनट. There is no need that why am I suffering so much. So first is 3 and then is a 1 and then is a 2. Okay, fine. Then we have 1 and then a 1 and then बेसिकली वो इंक्रीमेंट पहले हो जा रहा था, इंडेक्सिंग बाद में. गुड प्रॉब्लम फॉर. It's called a positive integer extreme round if it is only has one non-zero digit. For example, are extremely round elements one non-zero digit. Okay, हाँ ठीक है. This is div to a. Okay, int n, and basically let's convert it into a string. Uh, 2 underscore string n, and now I can iterate up to str count equals to 0. Count plus equals to it minus 0 not equal to 0. If count becomes greater than 1, no, else. Okay, and now I have to calculate the number of extremely round digits between n and tag. ये क्या कर दिया मैंने? Like okay, maybe I should read the problem first. I didn't think that. I thought that it was such an easy problem. So between 1 and x, I need to find the number of extremely round integers. Okay. Okay. Now this becomes a bit tough. Not used to Sublime at all. So now, can I iterate from 1 till n and then do this? Let's see if this gives me a TLE. This is order of n, 10 ki power 6 into some like 6 at max. Mhm. This should pass, I think. What if so? What is a better option? Let me just do one thing. No, this is good. Okay, again, but I'm not sure this will pass or not. This might lead to theory, and then I'll have to apply mathematics. Let's see what is the value of 3 seconds. Should pass. I think I feel like yeah, I got a theory. Hmm. So the thing is, I can skip a lot of things. Hmm. So this all uh, gives a TLE at the second disk itself. What if I pre-computed these values? Will that work? Like a sort of a prefix sum. Mhm. You see now if this works, because now I'm doing pre-computing would take huh. Mhm. Yeah. Okay. Given three integers n, a, and b, determine if there exist two combinations p and q of length n. The length of the common prefix is a, and the length of the common suffix is b. Mhm. Sunzara, sunzara, yes, yes, no. So basically, once a एन की एरे दी गई है, हमें बताना है कि क्या ऐसा पॉसिबल कि ए लेंथ का प्रीफिक्स दोनों में कॉमन है, बी लेंथ का सफिक्स दोनों में कॉमन है, यानी बाकी दोनों एलिमेंट्स डिफरेंट होने चाहिए। तो बी लेंथ का सफिक्स, सो पहली बात तो अगर बी और एन और बी और एन बराबर है, फिर ए और एन बराबर हो और दूसरा वाला एलिमेंट नहीं बराबर हो, तो आंसर नो हो जाएगा। अ, ठीक है ना। इंट एन ए कॉमा ए कॉमा बी, if a is equals to n and then b is not equals to n, or a is not equals to n and then b is equals to n, see out no, else क्या हो जाएगा कि a is equals to n, b is equals to n, answer is else क्या हो जाएगा n minus b, if it is more than 2 answer is yes, like 2 है तो अगर 1 1 कर लूँ मैं एक करूँ कुछ में तो या तो कितनी वैल्यूज पॉसिबल, 2 1 2 और 2 1, तो अब मैं कह रहा हूँ एक ये कॉमन है 1 2, एक ये कॉमन है तो यही हो गया ना, n माइनस a minus b less than equals to 1, answer is कांधे पे सूर्य बांधे चला के Okay, now we are done. I have solved all 31 problems and so pause. So it took me 1 hour 52 minutes. I started from problem 12th. So 12 till 19 problems and 1 hour 54 minutes. So calculator. So this is 104 divided by 19. That is 5.47 minutes per problem to be specific. Actually, 31 minus 12 is 19 plus 1 actually. Minus 11 it is 20. So okay, 101 114 divided by 20, it is 5.7 minutes per problem. Anyways, we are done with 800. So the next video we will start with 900s. So what did I learn after doing like 800 so much? The thing I learned is that many a times I need to read the problem very carefully. That would give me the solution itself. If I am also, I need to be sure that it is a 800 level problem. If it is an A or B problem, I don't have to like spend much brain on it. It must be direct. Like at maths, in all the things that I have done for like 800s, three things were very common. I found XOR, GCD, and counting, and then odd or even. That's it. This is everything that is covered in like 800 level problems like div 2 A is. And in one or two problem, like in one of these problems, which was like, mm, no, not this one, uh, extremely round. Like in here, I sort of thought that maybe it has to do something with maths. For example, uh, let's say I have to calculate till 40. Okay, then I'll take like, uh, over here I have one choice, and over here I have, over here I have less than equals to this choice. So it could be 10, 20, 30, and so on. And over similarly over here I have like nine choices. So in total this becomes 9, plus 4, so that is 13. And let's say if I had 1 and 3, so answer is 9 already. So now I just need to divide it, and then the answer would become, again 9, again 9, and so on. So like if it was 100, so it has 3 digits. So I have already added 9 here and 9 here, so that becomes 18. Then I'm saying that I can add plus 1, so that is just becomes 19, and 111 is just similar. Okay, so again, it was, if I see the tutorial, it's possible that it shows that I have to do using maths. The most naive solution, yeah. Hmm. There's also solution in O of 1 per test case with a formula. Try to invent it yourself. So we'll do that. We'll do just that. Let's try to do it. Okay. I'll submit this again. Okay. Now I'm saying I've been given a uh, an n, and so now we'll count the number of digits in n. Count is equals to 0. This x mod 10, while x is not equals to 0. X divided is equals to 10. Count plus plus. So this is the number of digits that are present in uh, n. Now the answer straight away is, answer would be, rem plus count into 9. Okay, yeah, sorry. This is what I feel the answer should be. Okay, I'm getting. तुम्हें जो मैंने देखा, तुम्हें जो मैंने जाना, मुझे 100, not 100, minus 1. The answer is this. Again, answer is, okay, sorry, n. Hmm. Answer is this, right? Huh. If I Even if I've applied maths, this does not increase the difficulty of problem that much. Like here it would have been n is less than equal to 10 to the power 18, and at max it would have become a div 2b. Then I'll start with 900, but I need. So did I hesitate in any of the problems? Let's see my submissions. How can I see? Let's see submissions. Okay. So one problem I got time limit exceeded, one I got wrong on test case 2. Otherwise, I think all of these problems I was able to do it in B sequence game. Uh, Sequence game was the first problem. Okay. Yeah, I was printing something else. Otherwise, it was a clean streak, and up till it should have been more cleaner and cleaner. I'm ending this video on this point. So basically, if you're just starting out with CPU or you will want to get better in solving the two A's and B's, just think that most of the times the answer is going to be direct. Don't have to think much.